Okay, let's run through these next few. Oh, excuse me. Here we have, this is how much we're starting with. So this would be our N0. And we're given the half-life, and we want to know N at time t. Okay, so guess what we need to do first? If you said, Dr. B, we need to find K, you're right. We need to find K. All right, so T half is going to be 0.693 divided by K, 3.8 days. So again, make sure you get your units of time correct. And then don't divide 3.8 by 0.693. The other way around. 0.182. This time I'm just going to write per day. Okay, you can also do this like we did with our rates, but I'm actually going to use this equation, N0 times e to the minus kt. We did do this in rates as far as like with the Arrhenius equation, but so this is what we're trying to solve for, N at time t. I'm just showing you several ways. You can plug it in just like this. It rearranges to this. This is the same process, okay? So don't panic that you need to learn another equation or anything. Just showing you a different application for those of you who might like a slightly different approach. If you like this better, plug and chug everything in here. If you don't like the natural log, you're gonna have to use a natural log, but if it's scary or weird to you, then don't worry about it. Negative K 0.182 per day times 3.8 days. Look, the days cancel out. So let's do that. Times 3.8. All right, and let's go with, oh, that was, no, it's not 3.8, it's times 5.5. That was the half-life, 5.5 days. Okay, so here, let's divide by 3.8. Okay, times 5.5. So let's go with e to the negative that number, multiply by our starting mass, 1.55. 0.568 grams. Don't forget your units on the end. Okay, next. A researcher claims it's from 500 BC. And this is its carbon decay ratio. And we want to know how old it is and could it be authentic. Okay, well, the good news is we know that the half-life of carbon-14 is 5715 years. That's pretty well known. So K is going to be 0.693 divided by, and you may even have that stored or referenced in your notes, which is fine. So it's a little number, 1.21 times 10 to the minus 4, and that's per year. Okay, so we're going to solve for time. You can use any of these equations you prefer. I'm going to use my standard first order rate law here. So here's my ratio, 0.89. If you want to put a 1, good for you. If you want to put 89 out of 100, good for you. It's going to work out the same way. Negative K, 1.21 times 10 to the negative 4th per year times T. Okay. So let's take natural log 0.89, divide by the negative answer. So T is 961 years. Okay, so let's think about this. 500 BC. This is currently 2021, so that's going to be about 2,500 years. 2,500 and 961. Those don't go together, so no, this is definitely not authentic. Handy tool. Some archaeologists don't really like it very much.